Hello. Pre-calculus 5.3, solving trigonometric equations. On 5.3, we're going to learn lots of different methods that you could use for solving trigonometric equations. For the first set of notes, we're just going to look at basic solving. A review from chapter 4, find all of the solutions between 0 to 2 pi. Not including 2 pi, but yes, including 0. So where is cosine x equal to negative square root 3 over 2? So I'm going to think about cosine being the x values. X values are negative to the left. So it could be in the second quadrant, or the third quadrant. That's where we could have negative cosine values. And then the rest of it should be somewhat memorized. What reference angle would this be to give cosine a radical 3 over 2? That should be a 30-degree reference angle, which is a pi over 6 reference angle. We are putting our answers in radians because you can read from the directions. In the second quadrant, pi over 6 would be 5 pi over 6. And in the third quadrant, 7 pi over 6. Right underneath it, it says now find all the solutions. So what I mean by all the solutions is instead of just the one solution, or the two, I should say, solutions between 0 to 2 pi, we can go around that circle as many times as we want. So instead of just going to 5 pi over 6, we could go all the way around again and hit that same location. And what we know about coterminal angles is that they are separated by 2 pi. So to find all the solutions, we're going to start with the original solution of 5 pi over 6, and we're going to add on 2 pi. But we're not just adding on one 2 pi. We could add on any number of 2 pi's as long as the 2 pi is an integer. So we're going to do what we did in chapter 4 with the asymptotes. We're going to add a variable. This time let's use an n. And then n has to be an integer. So now that takes care of this one. But we also have the third quadrant answer. And so I will have to write that one as a separate answer. So we're going to start at 7 pi over 6. And we're going to add on 2 pi, because that's what we need to get all the way around again. Multiply by that by any integer. And we will have all the solutions. So our next example is cosecant x is equal to 2. So that's positive. Cosecant is the reciprocal of sine, and sine is positive in the top 2 quadrants because sine is the y value. So we're going to have 2 answers, one in quadrant 1, one in quadrant 2. The only triangle that has a square root 2 in it is the 45, 45, 90. So these are going to be 45-degree reference angles, which are pi over 4. So in the first quadrant, x is pi over 4. In the second quadrant, 3 pi over 4. To find all the solutions, we're going to start with pi over 4. And we're going to add on 2 pi n, where n is an integer. And we will also take 3 pi over 4, and we'll add a full circle onto that, where n is an integer. All right, the third example, we've got cotangent is negative radical 3 over 3. That's the same thing as tangent of x equals negative square root 3. So tangent is negative or cotangent is negative in the second and fourth. We have a value of square root of 3 at a 60-degree reference, which is pi over 3. And so my first answer will be 2 pi over 3. My last answer will be 5 pi over 3. Now, to do all the solutions, tangent's a teeny tiny bit different, because when we look at tangent, the period for tangent, when we graphed it, or cotangent, I'm speaking of both of them at the same time, their period was just pi before they would repeat themselves again. So if I only went around half the circle, I would actually end up at the other answer that I got. So to write all the solutions, I just have to take the first answer, 2 pi over 3, and I'm only going to add on pi times n, where n is a integer, because that will give me the second integer or the second answer. And then if I add another pi on, then I'm getting another answer. And if I add another pi on, so it's going to hit both of those at every single pi value. So the amount that we're adding on, it really has to do with what the period of that cycle is. Now these, we're just going to solve the equation here. It's already solved with the exception of getting rid of cosine or cosecant. Here we're going to get the sine by itself and then do the inverse. The directions say between 0 to 2 pi without a calculator. So I'm going to have 2 sine x equals -1. Then I'm going to divide by 2. So sine x equals -1/2. So sine would be negative in the bottom 2 quadrants. It would be 1/2 at a 30-degree reference angle, which is a pi over 6. So our pi over 6 values in the third and fourth quadrant would be 7 pi over 6 and 11 pi over 6. All right, the next question, I'm going to solve for cosine x. So I'm first going to add the 3. 4 cosine squared x equals 3. Divide by 4. Cosine squared x equals 3/4. Now, to get cosine x by itself, I'm going to have to square root both sides. And we have a rule. If you square root, you got to put the plus minus in there too. So now I have a cosine x is equal to plus minus. When I square root a fraction, I can also square root the denominator and the numerator separately. So I'm going to get square root of 3 and square root of 4, which I can simplify. Plus minus square root 3 over 2. So now, because cosine is plus or minus, that is every single quadrant. All 4 quadrants. So I just need to know where cosine is a radical 3 over 2, which is a 30-degree reference angle, which is a pi over 6. So our answer is going to be all 4 pi over 6 angles. Okay, the next thing that we're going to do is secant x, parentheses, secant x minus 1. For this one, we will notice that we have something that is in factored form. We've got 2 separate factors being multiplied. We also have it equal to 0. If it is factored and it's equal to 0, we can solve by setting each separate factor equal to 0. Now I just have to figure out where secant x is 0 and where secant x is 1. So secant is the reciprocal of cosine. So if I use the reciprocal, then I would have to reciprocate 0, which is undefined. And there is no place where cosine is undefined. So this gives us no solution. Secant x, that would be the same place where, secant x equals 1 is the same place where cosine x equals 1, which is at 0. And we only have one solution for this one. All right, the next example, that's a lot like the previous example that we did like 2 examples ago. So we're going to solve for cosecant x first. I'm going to add the 4. Divide by 3. And then I'm going to square root both sides. And when I square root both sides, I do have to have a plus and a minus sign. So I get my cosecant x is equal to plus minus, I'm going to square root the top and the bottom separately, 2 over square root 3, which would be the exact same thing as the sine x is equal to plus minus square root 3 over 2. So again, when we have plus minus, it's going to be all 4 quadrants. And for square root 3 over 2 for sine, that is a 60-degree reference, or pi over 3. So this answer is going to have all 4 pi over 3 angles. All right, and then the last example, we have 2 factors equal to 0. So these 2 factors are being multiplied. They are equal to 0. So I can solve each individual factor by setting them equal to 0. Cotangent squared x equals 1/3. I'm going to square root both sides. I'm going to put plus minus in. And I'm going to get that cotangent x is equal to square root, and this ends up being square root 3 over 3. Then cotangent squared x equals 3. We're going to square root both sides, put in a plus minus. So we'll have cotangent x equals plus minus square root 3. And let's see. This one would be at the 30 degrees reference, which is the pi over 6's. This one would be 60 degrees, which is the pi over 3's. And since both of them are plus minus, we're going to have all 4 angles for each of them. You just need to put them in the correct order. So it might be helpful to sketch it. We've got pi over 6, which is 30. That's smaller than the pi over 3. Then our next one would be, I wrote pi over 6, sorry. Pi over 3. Then our next one would be 2 pi over 3. And then we would have 5 pi over 6. 7 pi over 6. 4 pi over 3. 5 pi over 3. And then 11 pi over 6. All right, the last thing I want to do is just show you that you can kind of use Desmos to check your answers a bit here. Go ahead and visit Desmos. You can also use your graphing calculator, but I don't have one to show you on here. So this one was 3 cotangent squared x minus 1. Multiplied by cotangent squared x minus 3. And then the second equation, or I'm sorry, it equals 0. So you can say for your second equation where y equals 0, or you can just find on the graph where y equals 0. And then the last thing that we're doing is we're going from 0 to 2 pi. So I'm going to change my step to count by pi over 2. And I'm going to just look at the part of the graph. Here, maybe I'll do it by hand. I'm going to look at the x-axis. So it's going from, let me just go from negative pi over 2 to 5 pi over 2. So that I can see pi over 2 in it. So we can see the graph from 0 to pi over 2. And then you can just like click where the two graphs intersect. And you can see the correct order. Oops, I went too far. You can see the correct order. You can see that there are 6 answers. Sorry, I can't count. 8 answers. 1, 2, 3, 4, 5, 6. Yep, 7, 8. So 8 answers. You can see that I had them in the correct order. So this would be a good way of checking your work until you feel pretty confident. All right, go ahead and work on your 5-3 worksheet number 1.